Okay, now we're going to be solving what we call literal equations, but this time we're solving quadratic literal equations. A literal equation is when you have a formula like this, and they are wanting you to solve for a different variable. So this is area of, I think it's surface area of a sphere. Right now it's solved for A, and they want us to solve for D. So we just have to, they're actually really, really simple. You just have to use the steps of getting D by itself, because right now D is not by itself. So the first thing I would do to isolate D is multiply both sides by 4. So that's going to give me 4a is pi d squared. And next thing I'm going to get rid of is that pi. So I can divide both sides by pi. And that gives me 4a over pi equals d squared. But I need d by itself, which means I'm going to need to take the square root of both sides. And that gives me d equals, now I'm going to write that as square root of 4a over square root of pi. These two things are exactly the same. But the reason I'm writing it this way is because there's not a problem with this square root of 4a that can be left in our equation, but you can't leave a square root in the denominator of a problem. That's a math rule. So we have to rationalize this. You rationalize by multiplying the denominator by itself, because remember we talked about a radical multiplied by itself just cancels the radical. But if I multiply the bottom by square root pi, I have to multiply the top by square root pi as well. So on bottom, square root of pi times square root of pi eliminates the radical and leaves me just pi. So there's no more radical in the denominator, which is why we did it. On top, all of these are under a house, so you can just put them all together in the same house. So 4a pi. It doesn't matter what order you put them in. You can put 4 pi a, it doesn't matter. You can't cancel these two pi's because this one's in the house and that one's not. So that's it. That's all you had to do. All right, so let's try another one of these. Let's see. How about, I have no idea what this is a formula for, and it actually may not be a formula for anything. It's just in the book as an example problem. They want us to solve for t. Problem with this is I have a t squared and a t in the same problem. Anytime you see that in algebra, that is your indication that this is going to have to all be moved to one side, and I'm either going to factor, complete the square, or use the quadratic formula. In this case, because it's a literal equation, I can't factor because I don't really have any numbers. So I'm going to move the k over and set it equal to 0. And I don't care if you want to complete the square if you're really good at that. I think that probably most of us would feel comfortable with the quadratic formula. So my a value is r, my b value is negative s, my c value is negative k. So I'm plugging into the quadratic formula. Remember, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. In this case, this x is actually a t. So t is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Now I'm just going to plug these into that and simplify if I can. So negative s plus or minus the square root of negative s squared minus 4 times r times negative k all over 2 times r. And now we're just simplifying, so negative becomes positive s plus or minus the square root of negative s squared is just going to be s squared minus r times negative k is going to be plus 4rk all over 2r. Now that's a perfectly fine answer. However, for MyLabs Plus, it wants you to, any fractions like this that have actually two pieces to them, split it up. So this denominator really belongs to both pieces of the fraction. So it's going to be s2r plus or minus the square root of s squared plus 4rk over 2r. And this is actually two answers there. So t equals s plus, and then t equals s minus. So that's it.